How many of you dread old age with wrinkly skin, weak muscles, and eyesight loss? Well, what if I told you you could have a body of a 30-year-old even when you're 60? Well, to understand this better, we must first know what aging is. All cells of a body contain chromosomes, and chromosomes contain end tips called telomeres. These telomeres could be thought of as like the end tips of shoelaces, which prevent the shoelaces from fraying. Every time a cell divides, the telomeres keep getting shorter and shorter, and at one point they become non-existent. That particular point is a sign of aging. Like this, there are 8 other factors that can show signs of aging, like mitochondrial dysfunction. But are these really the factors of aging, or is there a deeper root cause? Aging is a loss of information in the epigenome of our cells. So what is the epigenome? All cells of the body contain the exact same DNA, but different cell types from brain cells to skin cells contain different epigenomes. The epigenome is a packaging material that coils up the DNA in a certain manner so that only information from the DNA pertaining to a particular cell type is accessible for the creation of new cells. The epigenome is like an on-off switch for the DNA that lights up parts of the DNA useful for a particular cell type. They are controlled by a group of proteins called histones. The main function of histones is to bind the DNA together, allowing only some parts of the DNA to be read. Over a long period of time, all cells of our body get exposed to many external factors like intense sunlight, and this might cause chromosomes to break apart. To fix this problem, firstly the DNA of the cell must be unraveled, then proteins are supposed to be recruited to fix the problem, and finally the epigenome resets the cell back to its original state. During the time of reset, about 99% of the time it happens accurately, but at 1% of the time there is a flaw. That accumulation of flaws is called aging. To test this theory, 2 identical mice born on the exact same day were taken as test samples. One mouse was engineered to break chromosomes in its body easily, while the other mouse was untouched. Over a period, the engineered mouse was found to have more inaccurate placement of histones, shorter telomeres, and higher offset methylations compared to the normal mouse. This was one of the first proofs that aging was in fact caused by the loss of epigenetic information. Due to years of evolution through natural disasters like volcanoes, our body has developed 2 states of body function. During normal times, energy is prioritized for growth and reproduction, and during times of distress, energy is prioritized for protection and repair. So, to slow aging, we must ensure our bodies are in a continuous state of distress or discomfort. Epigenetics is a rapidly growing field, with even work being done to reverse aging. So very soon, aging might just as well become a thing of the past.